בוקר טוב, עולם שטוח 11. טוב, היום אנחנו ניגע בסוגיה שהיא שאלה שנשאלת. הרבה גלוב-הדס, או אנשים שמאמינים בכדור, הם הרי יודעים להסביר לא מסתדר בעולם השטוח הנושא של הטיסה מסנטיאגו מצ'ילה לסידני או בחזרה, שהטיסה היא מאוד קצרה כביכול. עכשיו, לא יודע, אני סתם עשיתי בדיקה מרופפת בשבילי, כן? מסנטיאגו לאזור אוסטרליה, אני לא ראיתי, ובדקתי, לא ראיתי שום טיסה ישירה. מסנטיאגו איך אומרים? לסידני או לאוסטרליה, אוקיי? תמיד יש להם שני עצירות, תמיד, לפחות שני עצירות, והטיסה היא ארוכה יחסית לכיוון אוסטרליה. בכיוון ההפוך תמיד אומרים, אבל הנה יש כזה טיסה מהירה, קצרה, 12 שעות, 13 שעות, כלום. איך זה? רק יכול להיות על כדור. טוב, אז יש פה עוד חבר טוב שיסביר לכם בצורה מדויקת מה יותר הגיוני, הכדור או העולם השטוח עם אותם נתונים. זה בדיוק מה שהגלובלס לא מבינים אף פעם. את אותם נתונים שסיפרו להם שקרים עליהם, אפשר לדבר עליהם ולהבין אותם בצורה אחרת לגמרי, רק אם מסתכלים. שימו לב.
We are here today to talk about the flight Sydney to Santiago. I have talked about this flight before in several videos, and it's also in my book on chapter 14, where I explain exactly how this flight works on the flat Earth. But for some people who still seem not to understand or haven't had the chance of looking at my past videos, I have decided to make this video today explaining once and for all how this flight Sydney to Santiago works. It's necessary that we look at both models. That's why we're going to be talking about the globe Earth model, the heliocentric model, and the flat Earth model. We have to look at those two models and understand how this flight takes place. So I'm going to start by asking you a simple question. How well do you know the heliocentric model? Now, according to the heliocentric model, Earth is spinning around its axis at 1,040 miles per hour. That equals to 1,600 kilometers per hour, approximately 460 meters per second, or 1,500 feet per second. Earth is also traveling around the Sun at 67,000 miles per hour, or 107,000 kilometers per hour, or about 30 kilometers per second, or 16 miles per second. The Sun is also traveling through space at 448,000 miles per hour. That equals to 720,000 kilometers per hour. In seconds, that equals to 230 kilometers per second, or around 142 miles per second. Not only that, the whole Milky Way, right now the Milky Way is racing through space at 1.4 million per hour. That equals to around 1,000 kilometers per second, or 622 miles per second. So we put it all together, and this is how it would look like on the heliocentric model. All these 4 movements are taking place at every second. Right now, while you're checking your phone or sipping a coffee, we have moved millions, thousands of kilometers through space. Now just imagine that in the midst of all of this, an airplane is flying upside down on the bottom of a spinning globe that's going through the universe at 1,000 kilometers per second, or 1.4 million miles per hour. Kind of difficult to understand, but this is what they say. It's happening right now. So we're gonna have to look at other details as we examine this flight. I have here a view of Earth, spinning Earth as seen from space. First one as seen from above the North Pole, the Arctic, and the second image is as seen from the bottom up towards Antarctica. That's a view. So imagine that the Earth is spinning and this flight is going from Sydney to Australia on this rotating Earth. Let's imagine that someone is in space looking at back through the rear view on the flight as the airplane is flying from Sydney to Santiago. Remember that the Earth is spinning. So someone in space would be able to observe the spin of the Earth and the airplane flying from Sydney to Santiago. According to the website, this flight takes 13 hours and about 30 minutes. I have rounded up to 13 hours, and just as I did with the flying over the North Pole video, we're gonna equal each hour 1 second. Every hour is gonna be counted as 1 second. So the Earth will be rotating for 13 seconds. Let's see, that's where the airplane is right now, where it will start. And let's see where it will end at the end of 13 seconds. So let's start the clock right now. So as you see, each second equals to 1 hour of flight. Earth is spinning. The airplane was in Sydney, but Sydney is rotating with the Earth. So at the end of 13 seconds, that's where Sydney is at this moment. So if you think about it, the airplane almost arrived at the same point in space where it took off. So the actual flight path of this airplane after 13 hours equals to this. It doesn't really make much sense, but this is what you have to believe it happened according to the heliocentric model. Beyond that, adding to this, remember that the whole Milky Way is racing through space at 1.4 million miles per hour. If you do the math, 1.4 million miles per hour times 13 hours of flight, at the end of this flight, this airplane moved through space 18,200,000 miles. So that's why I asked at the beginning this question. How well do you know the heliocentric model? Because I didn't know that, and I have come to understand that to believe in the heliocentric model takes a leap of faith. You have to believe those things are happening because there are no evidences that any of these movements are taking place, as we're gonna see next. Now, do you feel the rotation of the Earth, or do you feel any of these movements? An expert would come along and claim inertia. Inertia comes from, it's a Latin word. There are some advantages of speaking Latin language like I do, because you can understand the root of the word, where it comes from. So inertia literally means inactive, means not moving. If they say that you don't feel you're moving because of inertia, they really means you don't feel you're moving because you are not moving. You are inactive. Earth is inactive. Same thing with the word gravity, which is a Latin word that means weight. Comes from the Latin gravitas. So these people play with words, and as I believed the heliocentric model most of my life, I have seen some of dishonesty from the people who defended the heliocentric model. I believe they use a lot of dishonesty doing so.
I don't feel anything.
I don't feel anything.
I don't feel anything.
Well, that's a funny thing, actually. I really don't feel anything.
I can't feel shit. I can't feel anything.
I don't feel anything.
'Cause it's the strangest thing. I don't feel anything.
Now the experts will come to you and they will tell you, they will compare the movement of the Earth to be inside a moving train or an airplane. The expert will tell you, well, when you're inside the train, you throw a ball out and the ball falls back into your hands. That's their explanation why we don't feel anything. They compare being on the surface of the Earth as being inside the train or an airplane. Now, is the globe Earth traveling through space inside a train, airplane, or car? Where's the rooftop, shell, or fuselage? When I go outside, I don't see a rooftop or a giant windshield protecting Earth from the wind of being traveling in space at 1.4 million miles per hour. We see open skies when we go outside. When you're inside a car, train, or an airplane, all you see is the inside part of that particular means of transportation. You can't compare being in the open skies to being inside a shelled vehicle. All I see is open skies, beautiful open skies. I see stars during the night. I see the sun during the day, clouds moving everywhere. So it's wrong for them to compare being inside a train to being on the surface of the Earth. If they wanted to be honest, they should compare to being on top of a moving car, as this person here. They would see things are different. And why not compare to being on the top of an airplane? This would be an accurate way of comparing to being on the surface of Earth to being on a moving means of transportation, not being inside of it. Now, you have come to know the heliocentric model a little bit better. As I told you in the beginning, I didn't know much of this information. I didn't know that I was actually having faith in this model rather than knowing how it works. I just believed it because they told me. But once you start looking and start finding things that doesn't really make sense, all those four movements taking place at the same time, and nothing is felt by anybody, and neither any equipment has ever been able to detect any of these movements. Not only that, you need to understand that for this flight to be taking place, the Earth is also rotating and the airplane is chasing the city. For example, when an airplane leaves Sydney at, let's say, 500 miles per hour, but the Earth is rotating at the Tropic of Capricorn at 707 miles per hour. So the airplane is actually chasing Santiago. It just doesn't make any sense. And another small detail, this plane is also flying upside down. So all of this put together kind of makes difficult to believe this is how this flight really takes place. Now, the expert will come along and say the following. Well, the atmosphere is moving with the rotation of the Earth. I've heard these arguments before. It's kind of hard to believe this is what's going on, but there are also some contradictions within the heliocentric models. Let's look at one of them.
So what is the Coriolis effect? Well, it's what happens when objects moving in a straight line appear to curve because you are rotating, and it affects all kinds of things. It bends the paths of missiles and sniper shots. Have you ever seen someone in a movie making fine adjustments on their gun? Well, one effect they're correcting for is the Coriolis effect. The longest sniper shot, which was over 3,000 yards, would have had to correct for a 1-foot deviation due to the Coriolis effect.
So as the bullet leaves the barrel of the gun, the Earth is still rotating, and the bullet is not rotating with the Earth. So the Earth will actually rotate out from underneath of the bullet while it is in flight. So as the bullet leaves the barrel of the gun, the Earth is still rotating, and the bullet is not rotating with the Earth. And the bullet is not rotating with the Earth.
A 3,000-yard shoot needs a 1-foot correction, but a 7,000 miles long flight from Sydney to Santiago does not? This simple website that teaches Coriolis effect for kids, they show that a bird flying south, if the birds don't adjust for the spin of the Earth, they will miss their destination. In this case, the tropics of Rhombus is their destination, but as the Earth is spinning, they end up in Paralleloptopia. It's another island. So birds also have to adjust for the spin of the Earth when flying south, and not only snipers or missiles. Isn't that very selective from the Coriolis effect, that bullets and missiles and birds have to adjust but airplanes don't? Does this Big Bang favor airplanes over other equipments or other things that fly? It doesn't really make any sense. So if the atmosphere is moving with the Earth, why does it affect bullets, missiles and birds but don't affect airplanes? So that's another contradiction within the heliocentric model that makes no sense at all. We do not observe any movement of the Earth at all. It's not observable, it's not detectable because it's not moving. Just look at those beautiful images of Cappadocia in Turkey, where they have this hot air balloon festival. You just see how everything is calm and the balloons are flying over that region. Earth is not moving at 1.4 million miles per hour. Look what happened to someone who was just traveling at 50 miles per hour. And this car at only 70 miles per hour. And this person at 80 miles per hour, see the effects on his face. And they want us to believe the Earth is moving at 1.4 million per hour and we don't feel anything. Experiments have been made in the past to try to detect any movement of the Earth. One of the most famous is the Michelson-Morley experiment. There were other experiments made in history when they tried to detect any movement of the Earth. All of them fail. The Earth is at rest, it's motionless. It cannot be detected by any means. Einstein was here in Japan in the 1920s, and he was here in Kyoto, which is a city not far from where I live. In one of his lectures, he said to the Japanese public, "I have come to believe that the motion of the Earth cannot be detected by any optical experiment. Since the movement of the Earth cannot be detected by any optical experiment, the people who pushed the heliocentric model had just one other option. They adopted a philosophical position, and since then, with relativity, this is just a philosophical alternative to the fact that all experiments fail to detect any movement of the Earth." Here again are some images of beautiful Japan. This is not images from a place that it's going around its axis at 460 meters per second, or going around the sun at 30 kilometers per second, or chasing the sun in space at 230 kilometers per second, or moving with the galaxy at 1,000 kilometers per second. These are images of a motionless Earth. Earth is stationary, so we can eliminate the idea that a flight coming from Sydney to Santiago is flying over a spinning ball Earth going in 4 different directions at the same time at a speed of 1,000 kilometers per second or 1.4 million miles per hour. It's just not possible. we only have another option for that, which we will look at next. That's the flat Earth model. There are two polar streams and two subtropical streams on Earth. One polar stream goes around the Arctic, and the other one goes along the Antarctic Circle. These jet streams can reach a speed of up to 250 miles per hour, or 400 kilometers per hour. You can see here the wind currents going around the edge of the flat Earth. As you observe these jet streams with speeds that go up to 250 miles per hour or 400 kilometers per hour, the speed of the wind is added on top of the speed of the airplane.
The pilots also have maps of these well-known winds and flight plan calculation software, tools that allow them to avoid or alternatively use these wind currents in order to ensure maximum flight safety.
Here we have the winds, the jet streams and all the winds that was recorded in the year 2019. All this data was collected from 3 agencies. NOAA, the North American Agency, JMA, Japanese Meteorological Agency, and CMA, Chinese Meteorological Agency. Joe Gallian from the Philippines was the person who put all this data together and displayed on the flat Earth map. You can easily observe how these winds go on the face of the flat Earth. Here we have, with the red arrow, demonstrating how this flight from Sydney, Australia flies along the jet stream towards South America. This jet stream adds to the airplane a speed of another 200 to 250 miles per hour on top of the speed of the airplane. And there is no danger to the pilot, to the passengers, or to the aircraft, because the airplane is not flying against the wind currents. It's flying with the wind currents, being carried along with the wind currents. The same way, when flying back from South America towards Australia, there is also a jet stream and the airplane flies with it. When Max Egan flew from South America towards Australia, his compass favored the flat Earth map. We will see here how the globe Earth displayed on the seat back screen did not match his compass.
Getting a different reading from my compass. As business comes around, the reading stays the same. So they're giving me a reading of northwest. They're giving me a map direction of northwest. On my compass, I'm getting a reading from the southwest.
So, as you can see, the compass is clearly showing southwest or west-southwest, and the on-screen display is showing it is going northwest. Something is clearly weird about that particular flight, which seems to show northwest as the intended path of the flight, yet Max clearly showed, at least that portion of the flight was showing southwest on his compass, and he claims that it showed southwest the entire time he was awake. Let me show you a flat Earth map so you can get an idea of why that's a big deal. Now let me look at the flight as it would take place here on the Gleason's map. You can see the black line being the flight's path if it were on a flat Earth, and if you look at the lines that have the green on them, those are lines where the plane would be flying northwest. The line with the purple would be flying about west, and then all the yellow lines would be flying southwest. So the interesting thing there is, when Max said that the second half of his trip, the entire time he was awake, his compass was showing southwest, that would make sense with all the yellow lines, as you see. Remember, north is relative to where you're at, with south behind you, so that's what those little pink lines show us. And as you can see, all the yellow lines are actually a southwest flight direction, where on a globe, he should have been going northwest.
As we get to the end of this video, I want you to look at this image one more time and remember that all these 4 movements are happening right now as I speak. Earth is supposedly flying through space at a speed of 1,000 kilometers per second. That equals to 622 miles per second, or 1.4 million miles per hour. I find it very hard to believe that this is what is really going on. The only viable option that we face, the one that makes sense, that is in accord with our senses, with all the observations, with all the experiments, past and present, is that this flight takes place on a flat, non-rotating Earth. It makes sense when we looked at the flight paths on the flat Earth. It makes sense to our day-to-day experiences. The only obvious conclusion is that we are not living on a spinning ball Earth. We live on a flat, non-rotating Earth, as it is in accord with our senses, with common sense, with experiments past and present, and with our day-to-day observations. Earth is flat and stationary. Flights from Sydney, Australia to South America fly along the jet stream, and it flies over a flat, non-rotating Earth. Nobody's flying upside down when flying from Sydney to South America. Thank you very much. See you next time. Bye-bye.